Today's learning intention is called closed intervals. Our essential skills are calculating stationary values, that's the turning points of a function, and substituting x values back into original equations. So let's get started. Closed intervals. Sometimes it is necessary to restrict the part of the graph we are looking at using a closed interval. Now this is also sometimes called a restricted domain in your textbooks. The max and min values of the function can either be at the stationary points or at the end points of this closed interval. So below is a sketch of a curve with the closed interval between -2 and 6, and this has been shaded for you. Now as you can see, the maximum value occurs at the maximum turning point, but the minimum value occurs at the end point when x equals 6 and not the minimum turning point. Okay, so x equals 6, the graph is lower than the minimum turning point. To calculate the max and min values of a function within a restricted domain, we first of all find the stationary points using the derivative equal to 0. Sub into function to calculate the y-coordinate, that gives you the actual maximum or minimum value of the function. And calculate the value of the function at the end points of the domain, just in case they happen to be larger or smaller than your turning points. Let's look at example 1. A function is defined by f of x equals 2x cubed minus 5x squared minus 4x plus 1 within the domain when x is greater or equal to -1 but less than or equal to 4. It says find the maximum and minimum values of this function. So let's get started like normal. We take the function f of x equals 2x cubed minus 5x squared minus 4x plus 1, and then we take the derivative. In this example we've got 6x squared minus 10x minus 4. We write down at the stationary points f dash x equals 0, derivative equals 0. So we equate the derivative equal to 0, and then we're going to solve it to try and find where the stationary points are. Now we have to solve 6x squared minus 10x minus 4. Again, your first step is take out a common factor to simplify it. Factorise and solve. I've taken out a common factor of 2, and that leaves me with 2 times 3x squared minus 5x minus 2 equals 0. Now I have to factorise the quadratic, and that gives me 2 times 3x plus 1 times x minus 2 equal to 0. When I solve this, I've got 3x plus 1 equals 0, or x minus 2 equals 0, and that gives me stationary points at x equals -1/3 and x equals 2. Now I'm going to take those x coordinates and substitute them back into the function, and that gives me the y coordinates. So f of x equals 2x cubed minus 5x squared minus 4x plus 1. When x equals -1/3, I put that into the function. You can use your calculator and we get 46/27. Now remember to always try and simplify your fractions, but in this case that's in its simplest form. That tells me I've got a turning point at -1/3, 46/27. Now sometimes in the past papers you do get funny complicated fractions, and that's okay, you just leave it like that. That's one of the stationary points. When x equals 2, I put that into the function f at 2 equals -11. So that means I have another turning point, another stationary point at 2, -11. Now we could go and find out the nature, the maximum or minimums, but it's going to be a bit obvious in a second. We just look at the values. First of all, I'm going to have to check the value at the endpoints. So first endpoint, okay, x equals -1. I put that into the function f at -1 equals -2. So here we go, I'm looking at the coordinate point -1, -2. I'm then going to go to the other endpoint, which is x equals 4. F at 4 equals 33. So I'm considering the point 4, 33. Now the question says find the maximum and minimum values of f of x within this restricted domain. So the maximum value equals 33, and that occurs when x is 4 and the minimum value equals negative 11, and that occurs when x equals 2. Ready for another example now. Example 2. A function is defined by f of x equals x times x minus 3 squared. This has already been factorised for you, okay, and we want it between minus 2 and 5. So when x is greater than or equal to minus 2 or less than or equal to 5, and it said find the maximum and minimum values of this function. Example 2. A function is defined by f of x equals x times x minus 3 squared within the restricted domain from minus 2 to 5. It says find the maximum and minimum values of this function f of x. So we get started the exact same way. F of x equals x times x minus 3 squared. Now if I want to find the stationary points, I'm going to have to differentiate. Now before I can do that, I'm going to have to prepare to differentiate. So f of x equals x times x minus 3, x minus 3. Now you take the time to multiply out the brackets and then multiply through by 2, and you should get x cubed minus 6x squared plus 9x. So double check that for yourself. Now I can differentiate. The derivative of f dash x equals 3x squared minus 12x plus 9. Now if I want to find the stationary points, I'm going to have to state that at the stationary points, derivative equals 0. So I'm going to write out 3x squared minus 12x plus 9 equals 0. I'm going to have to factorise and solve. Now to make life easier, I'll take out a common factor of 3, and that gives me 3 times x squared minus 4x plus 3 equals 0. I now have to factorise the quadratic, and that gives me 3 times x minus 1, x minus 3 equals 0. When I try and solve that, I've either got the first bracket, x minus 1 is 0, or x minus 3 is 0 for the second bracket, and that gives me the stationary points are going to be located at x equals 1 and x equals 3. Now I'm trying to find the maximum and minimum values of f of x, so I need to substitute back into the function for these x values. Now when I do this, I'm going to go back and use the factorised form of the function, x times x minus 3 squared. So the first stationary point was at x equals 1, so I'm going to evaluate the function when x is 1. So the function when x is 1 equals 1 times 1 minus 3 squared, and that gives me 4. So I'm going to have to consider the turning point at 1, 4. The other turning point was when x is 3, so I evaluate the function when f at 3 equals 0. So the other stationary point's at 3, 0. Before I can finish off here, I'm going to have to check the value at these endpoints. The endpoints were when x is minus 2 and when x is 5. So when x equals minus 2, f at minus 2 equals negative 50. So I need to consider the point minus 2 minus 50. And when x equals 5, function at 5 equals 20. So consider the point 5, 20. So which one has got the maximum value and which one has the minimum value? I'm looking for the largest y coordinate and the smallest y coordinate. Stated, the maximum value equals 20 at x equals 5, and the minimum value equals negative 50 at x equals negative 2.
Now try these examples on your own. Please pause the video. And the solutions for A, the maximum value is 400 over 27, and that occurs at a stationary point when x equals negative 8 over 3. And the minimum value is negative 36. And again, that's at another stationary point, and that's when x is 2. And then in example B, the maximum value occurs at an end point this time. So the maximum value is 11 when x is negative 1. And the minimum value is negative 16, and that's a stationary point when x equals 2.
Well, we learned how to calculate the max and min values of a function within a closed interval. The key steps were to differentiate the curve's equation, set the derivative equal to 0, factorise and solve to find x coordinates of the stationary points. So that's normally what we do to find the stationary points. However, the max and min values might be at the end of the interval. So we also substitute the x coordinate into the curve's equation to obtain y, and then we check the values at the endpoints of the closed intervals. State the max and min values.
Now try these examples on your own. Please pause the video. And the solutions for A, the maximum value is 400 over 27, and that occurs at a stationary point when x equals negative 8 over 3. And the minimum value is negative 36. And again, that's at another stationary point, and that's when x is 2. And then in example B, the maximum value occurs at an end point this time. So the maximum value is 11 when x is negative 1. And the minimum value is negative 16, and that's at a stationary point when x equals 2.